Okay, so for the last one that we have, you'll notice that we have the domain between negative pi and positive pi. So I've drawn down here. It's a bit hard to see, sorry. If you want to copy this, so we've gone pi onto pi, negative pi onto and pi, because that's what our domain is. And what I've drawn on there to begin with is just the plain normal cos graph in that circumstance. But you will see that I've broken up to here. If you're trying to read this, it's minus a half, minus 1, half, 1, 3 on 2. Because, as you can see at the bottom, at the end of the graph, we have to add a half. And we also have to inverse the graph. So if this is the beginning of the graph as just a plain cos graph, let's throw it upside down to be inverse. Okay. So to begin with, we are going to go backwards from what we've got and draw the inverse of our cos graph. Now, just to make it easier for you, I hope, I'm going to get rid of that original one so we don't confuse ourselves. All right, so what have we tackled for the moment? All we have is an inverse cos graph, but we do have it between negative pi and pi, okay, which is our restrictions up here, which is good. I'm happy with that so far. All right, so the next thing we're going to deal with is that we're going to move the graph up by a half at each of these spots. So our negative 1 is going to go to negative a half. This is 0. It's going to go up to a half. 0 up to a half. And then our 1 is going to start at 1.5. Okay, so now you can draw the graph again, but this time you have translated it up by a half on the y-axis. Okay, now I'm hoping this is working, although we get rid of the points, sorry. So this is where you should be at now, and the last thing that we need to do is move it to the left, pi on 2. And you'll notice here I've divided it into, this says negative pi on 2. So we're going to move that one across. We're going to move this one across. I'm going to stop. We don't need to move that across because this is where we need to start. So we've done this one and this one. The next one is going to be on 0 half. This one is going to be on pi over 2. So our graph will look like this, knowing that we do need to go up to pi. And we know the shape of the graph. So the end point there should be pi half, okay? And this end point here is negative pi half. Now, you do need to be able to show that as well. All right, so up here it says labeling all endpoints and intercepts. And while this one is easy, okay, we haven't shown yet what our intercepts now are, which is here and here on our new graph. I'll just make that a little bit denser so you know which one is the one that we're aiming for at this stage. Okay, so the things we don't have here, all the other ones are okay, we know what they are, but we don't have the x-intercepts. Okay, so we're going to find them now. So if we come back up here and we do that, well, so we're going to do x-intercept, let y equals 0. Okay, so 0 equals minus cos x plus pi on 2 plus a half. Okay, if we subtract a half, both sides, so then we've got this line. And then, of course, we can get rid of our halves. So if we divide everything by half, we'll end up with cos x plus pi on 2 is equal to 1/2. Now, we know from our unit circle that cos theta, if we want it to equal 1/2, then theta is equal to pi on 3. So instead of that, we're going to say that x plus pi on 2, which is like our theta, is equal to pi on 3. Okay, we still have to work out what these values are. Now, we hope that they're negative values because obviously our graph is in the negative over there. So we hope that that's going to come out and work. All right, so we also know, we want to know where cos is positive because this is a positive value. So we know they're all positive in the first quadrant and cos is positive in the fourth quadrant. All right, so we are going to have a look at these two values here. All right, not just the pi on 3, which would be here, but also negative pi on 3. So we need to change this to be x plus pi on 2 can equal negative pi on 3 or pi on 3. Sorry, I'm running out of room here. All right, so if we add pi on 2 to both sides, we're going to end up with x equals negative pi on 3 plus pi on 2, and x also equals pi on 3 plus pi on 2. So our new values, negative pi on 3, oh, it should be minus, sorry. Hopefully you got that and you're saying Mrs. Thomas is wrong. Okay, so from here, and I've totally run out of room, I'm going to go down here. So our values are x equals minus pi on 3 minus pi on 2, or x equal, and I should say, pi on 3 minus pi on 2, two values, and we should end up with negative 5 pi on 6 and negative pi on 6. Okay, so the 2 points are negative 5 pi on 6, 0, and negative pi on 6, 0. Let's just have a look and see if that looks like it could be right. Okay, so here we've got pi on 2, negative pi on 2. So negative pi on 6 is going to be less than that, so it must be this point. And negative 5 pi on 6 is almost negative pi, so it must be this point. Okay, so they're your 2 points. Hopefully your graph looks not as messy as mine. I'm very sorry about the way it looks. And you can put these values into your graph. So just be careful that you always read the questions. So this one says labelling all endpoints and intercepts, which is now what we've done.